Today I'll be continuing my lesson on the quadratic equation. All right, mainly we are doing the solving quadratic equation and those those problem sums kind of question. Ken, hello, Ice, are you there? Ice? No, maybe you go toilet.
Yeah.
Yeah. Oh, okay. Hey, you're late, but it's okay. All right, haven't really started yet. All right, so Ice, your WA, right? You managed to get the results back already? For
Yeah.
math? Okay, do you mind going to the chat and type out your results to me? You can give me a direct message lah. Right, so that keep it private lah. Some of you don't want to know. All right, so if you don't mind, thank you so much. Okay, so this was the homework that I left behind last week. All right, this topic is actually called map and scale. Can I just check with you? How many of you done this topic as your first topic? Ezekiel, have you seen this topic before? Map and scale? Ezekiel?
No.
Never see this topic. Sherman, Sherman?
No.
No. Zen?
No.
No. Ice, have you seen this type of question before?
No.
Okay, very good. All right. Why I say very good? Because this topic is actually being removed out from your Sec 2 actually. All right. But there are still some schools who did it. All right. And I think that this topic, right, is actually very easy. Right? It's actually very easy. And I just want to show it to you. All right. Just in case if your teacher asks it, you know what to do. All right. This topic is actually called map and scale. All right. It has been removed from your syllabus already. It's not found in your textbook. I know. All right. But just give me a quick, let's say 3 minutes to finish this question. All right. Just in case your teacher, they lost touch and they are still asking this out question. Okay, so what is happening is for map and scale, right? You are actually drawing a map that represents the actual area. All right, so you cannot draw to scale because that would be crazy. All right, for example, the actual area is like the size of Singapore. Are you going to draw the whole entire Singapore on a map? It's not possible, you see. All right, so you can draw a smaller scale of Singapore on a map. That's okay. So down here, right, usually they will start off with 1 cm representing 200 meter. This 1 cm, right, actually is what we call the map. It's like the drawing versus the actual. It's always like that. All right, we compare map versus actual. So the meaning of map means it's like fake lah. All right, it's like a scale drawing. So down here, they ask you, find the scale of the map in the ratio of 1:n. So just to let you guys know about ratio, every time you compare ratio, right? For example, you compare money in dollars with money in dollars. That is called fairness. And therefore, the ratio will be what? 1:5. However, the units, right, must be the same, dollar and dollar. But down here is in meters, you see, no? Right? It's not fair. So you must compare them in terms of the centimeter in this case. So 200 meter, right? I purposely times 100, right? To give me what? 1, 2, 3 centimeter. Can you see? So 1 cm on the map, the fake one, represents 20,000 centimeter on the actual. How do I get 20,000? Simply because 1 meter is equal to 100 cm lah. All right, this is the normal conversion that you should know. So 200 meter is simply 20,000 centimeter. And can you see that by units is the same already? Yes. Then you can safely say that the ratio is 1:20,000. Easy or not? Easy, right? Yeah. I don't understand why this topic is being removed. All right, it should be given to you so that it will be an easy topic for you. But anyway, don't care. All right. So the next part of the question, let's take a look. Two towns A and B are 15 kilometers apart. All right. So what do you have? The question gives me 1 cm is to 200 meter. All right. So I know that 1 cm represents 200 meter. And this 1 cm represents the map or the fake. And this 200 actually means the actual. All right. It's always like that. But the question is asking about 15 kilometer. Oh, the conversion from kilometer to meter. All right. This one must know. All right. The K means 1,000. All right, so it's times 1000. Meter back to kilometer is divide by 1000. All right, so 15 kilometer is actually 15 times 1000. That will be 15,000 meter. So the actual distance between two towns is 15,000 meter. The 15,000 meter you can put down here like that. 15,000 meter. All right, so they want to find the map. How many cm down here? Can you see? So what do I do? This topic is something called rate. From 200, how do you get to 15,000? It's a multiplication of what? 200 times what is 15,000? Press your calculator. 15,000 divided by 200. Oh, it's actually 75. All right, if you don't believe, you can press your calculator. 200 times 75 is 15,000. So if you do that on the right, remember to do that on the left. That's called fairness. And therefore, the answer is 75 centimeter. So 75 centimeter on the map represents the distance of 15 kilometer between town A and B. Can? All right. And the last part, right, is what we talk about something called kilometer squared and cm squared. So when you see this, right, this is what we call like the area scale. All right. So how do you adjust your length scale to becomes your area scale? All right, let's take it out. Let's take a look. All right. So we have something called 1 cm is to 200 meters once again. This 1 cm is like the map, which is the fake, and this one is the actual. Okay. So I take a look at the question. The question is looking for kilometer squared versus cm squared. So I have cm down here, but down here is a meter. I want kilometer. So how? So back to here, meter to kilometer is a divide by 1000. You can adjust. So 200 divided by 1000. That actually gives you, press your calculator, 200 divided by 1000. It actually gives you a 0.2 kilometer. So actually, you can say that 1 cm on the map represents 0.2 kilometer. Hey, but sure, this is what you call a length. Length is talking about a distance. All right, length is talking about a distance. But down here, we're talking about area scale. Okay, so what you do? All right, this one, I think you should know. Reason why is because Sec 3, they'll be asking about this. Can? From length to area, all you got to do is to square it. Very easy. All right, from length to area, all you got to do is to square it. All right, because the area, right, got something called the kilometer square, cm square. There's a square behind. So all you got to do is to square it. If they ask you for volume scale, all you got to do is to cube it. That's the beauty of mathematics, children. Seriously. All right, area is to square it. Why? Because it's got cm squared, kilometer squared. Why? All right, how do you find the volume? Volume is what? Cm cube, right? Meter cube, got a cube, right? So you have to cube it. All right, that is the best part of mathematics. All right, so it's not really difficult. All right, you don't pressure yourself too much. All right, keep trying. Eventually, you will do well. Can? So down here, let me continue. 1 cm times 1 cm is what? 1 times 1 is 1. Cm times cm is cm square. 0.2 times 0.2, because it's a square, right? So 0.2 times 0.2 is 0.04. Kilometer times kilometer is kilometer square. Now the questions want what? The question wants 250 cm squared. So 250, you put it down here. They are looking for the answer in kilometer squared. So this is the answer that they're looking for. Once again, what do you do? Ask yourself, from 1, how do you get to 250? You must times 250. If you do that on the left, you must do that on the right, times 250. So 0.04 times 250 will give you a 10. Voila. Can you see now, children? Very easy, right? This topic of math and skill is actually very simple, right? But they remove it, too bad for you. Can? But if you still see it, right? If you still see it sometimes, right? At least have an idea that I taught you something like that before. All right? Always have an idea. Then from there, you can say, yeah, I know this. Then you can have a bit more confidence to progress on. Is that okay? All right. So I want to apologize to Ezekiel and Zen. All right. The reason why is because as you can see, I talk a lot, right? And because I talk a lot, right? I tend to give you all a little bit more extra thing, All right, hope you all don't mind. All right, and because of me giving you all extra thing, right? This week is supposed to be the worksheet 10. All right, it's supposed to be the week 10 or the tutorial 10. All right, but I didn't manage to finish up my previous week work. All right, so I'm still stuck at worksheet 9, All right, I'm so sorry. All right. So worksheet 9 and worksheet 10 is related to quadratic equation. All right. Worksheet 9 is talking about the quadratic equation, forming of the equation to solve the word problems. Worksheet 10 is about graph drawing. All right. So today we are still on worksheet 9. If at the end of the lesson still got time, I may go into worksheet 10. But honestly, I doubt so. This topic is a very big topic. All right. So I'm just want to apologize for that. All right. So here is worksheet 9. Okay. All right, so worksheet 9, we are talking about some real life problem involving quadratic equation in the form of distance speed time. DST is distance speed time. Geometric figures, all right, it's like, some area and perimeter and all this, and something to do with arithmetic. Can? All right, so before that, right, I would like to start off with something called a quick note. So this quick note, I think, is important. So I would hope, right, I will hope that you guys have an exercise book and you can actually write down with me these quick notes. Of course, you can do a screenshot and all this. You guys are very good, right? You can even take your phone and to take capture a picture on this. Can? All right. So today, right, I want to talk a little bit about fractions. All right. I want to talk a little bit about fractions. Okay, it's quadratic equation related lah. So don't worry. All right. So for example, I have a question like this. Let's say 50 over x minus 10 x minus 15 is equal to half. I know some of you say, you don't like fractions. Yeah, many of my students, they don't like fractions, right? They don't like fractions. So down here, what can I do? All right, at this moment, what can I do? Obviously, the question is asking you to solve. And remember the last lesson I taught you all? All right, the meaning of solve means what? If you can recall, the meaning of solve means to find x, to find the unknown. All right, to find the unknown. And very importantly, there are two things that you need to recall for me. Number one, all right, whatever must be equal to 0. Right, you must have this equal to 0 part. And number two, always what? Factorize before solving. All right, this is what I taught the class last week. Always factorize before solving. Can? So every topic, right, there's some important things to remember. All right, so please try to remember all these little things. Can? Okay, come. Anyone? All right, anyone know what should I do with this? All right, this is what they write, 50 over x, is it? All right, this is a fraction minus 10 over x minus 15 is equal to half. All right, so the first thing you take a look, I don't like fractions. Okay, then how? So how do we get rid of the fractions? How? Anyone got any idea? Sherman, any idea or not? How to get rid of the fractions? Sherman? No. You will say no. Sherman very cool one, I don't know why. Right, he always, the answer all very cool one. Right, so Sherman got any idea or not? No, you don't answer me.
No.
You see? All right. So how do you handle this type of fraction? Okay, let me just show it to you first. All right, so that next time you all can remember, can? All right, how do you handle this type of fraction? All right, the first method one. There are two methods. Which method is good? You choose, can? All right, method one is to what? Common denominator. Common denominator. All right, so down here, right, the denominator is an x. The next denominator is an x minus 15. So how? How do you combine them into a single fraction? Have you heard of this before? Single fraction? Yes, right, you heard of this before, definitely. So these two fractions, right, you try to combine them into a single fraction. What you do? You take x and also x minus 15. All right, as the common denominator. So for the first fraction, what do I need? I need to multiply by a x minus 15 in order to get to the denominator. The second fraction, I need to times x in order to get to the denominator. So if I do that to the denominator, I need to do that to my numerator also. All right, whatever you do to the denominator, you must do it to the denominator. So if you can look at the color, all right, 50, right, I also need to multiply by x minus 15.